Okay, so we're off for Labor Day. So on next time I see you on the 31st, I'll ask to see if you have any homework questions. So bring anything that you're struggling with. We'll spend the whole day just going over problems. Okay. Today will be the last day on material for exam 1. Then the following week, when we get back after Labor Day on the 7th, we'll just start reviewing for the exam. So all week, just review, doing practice problems over and over again. All the review questions and problems we do together will be similar to the ones you see on your exam. Okay. So I try to choose questions that we've either done together from your homework or from the review. So if you can do any of those, you should be good. Okay. And then on the 12th, when we get back, after all of that, we'll have our exam. So I'm giving you a lot of heads up. Monday. Okay. So if you can try to get all your homework done this week, that way you can just spend your time reviewing. But I'll probably push back chapter 6 to next week. All chapter 5 will be due this Sunday. So you still have a lot of time. Okay. And if there's any issues, let me know. It's not a big deal. But right now we have a ton of time still. So I'm going to try to keep preparing and reviewing. Okay. Any questions on this? All right. Well, let's get to it then. So 6.3. Do you guys remember your college algebra? About inverse functions? Like, do you remember what was required to have an inverse? Let's see. Like, do you all agree that the inverse of x squared is the square root function? Right? They're opposites. But we couldn't define it unless the function was 1-to-1. Okay. So the idea was way back whenever you took college algebra or maybe in high school, I don't know when you did that stuff. We had to cut the parabola in half and say it's only defined from 0 to infinity. Once it was cut, then you can define the square root function. So you can't have an inverse unless it is 1-to-1. Do you remember the definition of 1-to-1? Or back then you had definition of a function, definition of we used the vertical line test. Remember that? Then we had a horizontal line test. So if it passed the horizontal, then it was 1-to-1. So every input had exactly one output. That was the definition of 1-to-1. For example, right here, the parabola, the value 2 and -2 go to the same place, right? Right there somewhere. 4, right? Can't seem to. It won't click for me today. I'll just draw some lines. Okay. No, 2, not 4. Okay. So as you can see, the value 2 and -2 go to the same place, right? Because if you plug it in, you're going to get a 4. Right? You square a negative or a positive, you get the same thing. So that violates the definition of 1-to-1. So we had to restrict the domain. So that's how they define the inverse functions in trigonometry. So they have to basically cut it off, because you know how the functions go on forever. If you looked at 6.1 and 6.2, they are cyclical graphs, right? They go on forever, so we have to redefine their domain. So for the sine, let's do cosine. For the cosine, we have to cut it off here and here. So what they do is they use this as your function, and then they define the inverse based on just that segment. So if you read the book for today, the notes for today, let me zoom in because for some reason it looks like garbage up here when I put text. Can you see the picture? Yeah. It's a little better, right? So for the sine function, they just define from negative pi over 2 to pi over 2. So when we start doing problems involving the inverse sine, you have to only use those values, okay? Cosine is from 0 to pi, as you can see the domain here. So when we solve the questions, you should only use those angles, okay? We can go outside. So for the easy way to remember, for sine inverse, the range values, the angles we'll be dealing with is only on the right half of the circle. For cosine inverse is going to be the top half. So only use those on the homework questions, okay? Tangent inverse will be the right half as well, and everything else will be based on that, okay? And you can always write those down on a note sheet. It's also on that PDF I sent you Friday. Domain and range are all in here. So use these as well to help you out to remember, okay? So anyway, since what we've been doing, right, we plug in an angle and we get a value, right? So that's what we did last week and the week before. So the inverse will be the opposite. You put in a value and you get your angle. So the question becomes for number one, where is that homework? For number one, find the exact value. Part A. So sine inverse of square root 3 over 2. So remember in the notes that the range of values for the angles have to be here. To answer this question. So again, regular sine meant you plug in an angle and you find the y value, right? So inverse sine, you put in a value and then you find where that angle is going to be at. So it's the opposite. So in plain English, right? This guy right here means find the angle, or what is the angle whose sine is square root 3 over 2. Does that make sense? That's what that statement is asking. So this is the math symbols for this question. Okay. I should share screen so you can record everything. I have too much garbage open. All right, so for that question, number one on your homework, you zoom out a little bit. Where is sine equal to square root 3 over 2? Which y value is square root 3 over 2? But the y value, right? 3 over 2. Yeah, it's going to be pi over 3 or 60 degrees. So the y value is the root of 2. Yeah. So since it's there, then you choose that angle. But just remember, you have to choose from 0 to pi over 2 or 0 to negative pi over 2. Don't use anything over here, okay, for these questions. Does that make sense? So the answer for this, and if you read the section, right, there's a definition that tells you one second. This is looking for some angle, right? So we find that to be 60 degrees, right? That's what we said. So we can rewrite this using the definition. So this is the answer. We're done. Just to mention the definition, because I don't know if you've looked at it, the notes yet or the book. Using the definition, this is like saying that sine of 60 is equal to square root 3 over 2. So this is this type of stuff we did at the beginning of chapter 5 or 6, right? We just plugged in 60 degrees in sine and we found the y value. So these right here, these two things are the same, right? They're just written differently. Does that make sense? So by definition, you can rewrite the sine inverse of a value equal to an angle as sine of that angle equal to the value. Okay. They didn't ask for this. I'm just mentioning the definition. That's it. Okay, this is applying the definition here. We're gonna need it later, but not right now. Not right now. In the later examples, we'll need this definition. So any questions? Like, does it make sense what we're doing here? Right. Okay. So you plug in a value and you find the angle. That's it. Yes.
What's the point of the I two? Like, I still don't understand that.
This part?
Yeah.
So basically, this is telling us which angles we can choose. So we're restricting the function. So if we go back to the circle here, we have to go from 0 to pi over 2 as a solution. So I can only pick values in there. So I could write it as, if you want, negative 90 degrees to 90 degrees. That'd be the same thing.
So if it was like 3 pi over 2 and 8.
Yeah, 3 pi over 2 would be too big, so it would not be within those values because it would go all the way around. So you want to, instead of 3 pi over 2, you want to use negative pi over 2. That way, because it would be undefined. Because remember, we restricted that original function to make it 1-to-1. So if it's not restricted, we can't use these values. If you were to use your calculator, it would give you the negative angle because of the definition. Okay. Even though their coterminal is the same, for these questions, it would be counted wrong. So make sure you stick to values in here or in there. That's why we chose this. We'll do some more so you can see what I'm talking about. But let's do a cosine first. The cosine inverse of -1. And remember that we have to be within 0 to pi for cosine, or 0 to 180 degrees, same thing. You'll go back to your circle. Where is there a cosine value of -1? So which angle gives you an x value of -1? Yeah, 180 or pi, right? So that'd be your solution. So the question's asking again. So here's the answer.
How do you know, like, the restrictions? How do you know, like,
it's going to be in the notes that I gave you, that page. So look at the restrictions. But yeah, I would just make a note to yourself when you're doing it. That way you know, okay, don't look outside of here, or it'll be only defined in this section. So I won't make you memorize it, but that PDF I sent you earlier, I think it's in here. Where is it? This one. This guy right here. Where is cosine? Okay. No, I don't think it is in here. I thought it was. So it's in 6.3. Restricted domain for sine is negative pi over 2 to pi over 2. Cosine 0 to pi, and then the tangent is here. Almost the same as cosine, but do not include the endpoints. Okay. So make sure you have those. So again, before every class, just look through the notes, that section, and just write down all the formulas. Okay. Just to save some time. But I'll write them down right here for you real quick. Make it back to I guess I can put them on this corner. Sine inverse. The values that we're going to be looking for. Cosine inverse restriction would be 0 to pi. Tangent inverse will be parentheses, not bracket, negative pi over 2 to pi over 2. Yeah. Okay. Just so we don't forget, in case you don't have them, there they are. All right, so back to part B. Was there any other questions? Make sense so far? All right. What is the angle? So this is asking. Whose cosine is -1. And we looked at the circle and we found it to be what? Yeah, 180 or pi. Doesn't matter. Okay. So that's my answer right there. If you were to apply the definition just for fun, cosine of 180 degrees is equal to -1. Right? We're going to need that later. So that's number 1 in your homework here. Okay. It's a little better. Anyway, so that's all I want you to do here. So they see how they say exact value. Don't use a calculator. Just use a circle. That way you give it the exact angle. Okay. I mean, technically you would be fine on this one, but you want to get in the habit of using your circle. Okay. Let's do number 2 here. So sine inverse of a half, cosine inverse of a half, and then this guy. Okay. All right. I'm gonna box the answer just so I don't confuse you later, because this was just extra stuff here. Did it for fun, not for any real reason. Okay. I don't want you to look at this later and like, why? What is this? Why did he do that? Like, just for practice. That's it. The question stopped here. Find the exact value of the following. So part A, sine inverse of 1/2. So look at your circle. What is the angle that gives me a sine value of 1/2? Yeah, let's do it. Okay. So remember, where sine inverse is the right half of your circle. What angle is giving me a 1/2 for the sine value? Yeah, it's going to be 30 degrees, right? Has to be the y, don't forget. Okay, part B was cosine of 1/2. Let's go ahead and do that real quick. Cosine is the top half of the circle. What angle gives me 1/2 for the cosine value? Yeah, it's going to be 60. And the last one was cosine inverse of 9. So if you, I'm hoping you looked at chapter 6 a little bit. What were where's the biggest value sine and cosine can be? Like the highest point and lowest point? Right? It goes on forever, but it has a peak and a minimum, right? You know what? It might help to look at the circle. Right? The angles go on forever, right? Those are the x values. But the outputs are out here. These are the range values. It's in the name, right? Unit circle. What's the biggest thing on there? It's not a trick. Unit means one, right? So biggest is one. Doesn't go beyond the one. So does this question make any sense? How do you get a 9 if the biggest is 1? Yeah, it's not going to happen, right? It's not defined. If you put this in your calculator, you're going to get an error. The biggest thing you should have inside an inverse function will be 1 to -1. So those values. Biggest would be 1, lowest would be -1. Okay, anything else between there is fine. But if you go outside, you're not going to find a value because it doesn't exist. Okay. Does that make sense?
Yeah.
Any questions on number 2? That's all they're doing here. Let me open the homework up again. That's all they want. If I click it, they have a different version, but who cares? So just type it in, you'll be good. I think that's straightforward, right? Or is that weird? Does it make sense? Let me know. If I make no sense, just tell me. Don't get mad or anything. Let's do something more difficult. Is that cool? Or if you want another one of these, let me know. I'm gonna do something different. Here we go. To complete the identity using the triangle method. So this for sure will be on your exam. I like this question. They give you a cosine and then the tangent inverse inside. So they want, basically what they're asking is find cosine given that information. So what is cosine knowing that tangent of inverse of x is inside? So you have to build the triangle. You guys cool on this page? Let me know. If I go too fast, just tell me. Question was complete the identity. Using the triangle method. Okay. So this is when the definition becomes useful. So what you should do, the easiest way to think about it is remember, anything inside of a cosine is technically an angle, right? So this is some angle. So let theta that represents some angle equal to the inside piece. Then apply the definition that we were using earlier. So this means that there exists some angle that will give me a x value, right? You see how these are the same. That's how you apply the definition. You're going to have to use the definition every single time on these types of questions. Once you have it in terms of tan theta, build your triangle. That's what they mean by triangle method. Build your triangle and remember that you can write anything over 1 whenever you feel like it. So tangent is equal to the opposite over adjacent, right? Opposite, I put theta there, so opposite's here. Adjacent is there. So far, you guys still with me? That makes sense? Okay. At this point, solve the hypotenuse, which will give you x squared plus 1. Remember that c squared is equal to a squared plus b squared. Solve for c. That'll get you to here, right? I'm going to skip this step. Is that okay? You would square both of them, right? X squared is that. 1 squared is 1. If you have any questions on this, let me know. But the important part is using the definition. Once you get here, draw your triangle and then answer the question. The question is asking you, what is cosine once you have your triangle? What is cosine? It's going to be adjacent over the hypotenuse. That's it.
So for the x on the hypotenuse, the tan of the x, so like there's like an imaginary one.
Right. So this is the opposite side, adjacent side. So put the 1 there. That way you can build a triangle. You can put it anytime you want. So this question is just asking for this. If you don't rationalize on the test, it's fine. Man, that's good enough for me. The homework may ask you to. I'm not sure. You'll have to check it. Any questions on these steps, though?
What's the square root of x squared plus 1?
No, you have to solve for the hypotenuse. So you can call either one A or B, doesn't matter. So you can say that this is, I said that this was A, and this was B, right? Doesn't matter, you can switch it. The only thing that matters is hypotenuse, because that's always specific. Okay. I'll show my work on the next one if it bothers people. No big deal. Any other questions on part A? Is it all right? Okay. The sine of secant inverse, same deal. Let theta equal secant inverse of x. Apply your definition. That's the same as saying secant of theta is equal to some x, which will be x over 1 just to build our triangle. At this point, draw your triangle. What was secant based on the definitions? You remember? Yeah, it's going to be hypotenuse over adjacent because it's the reciprocal of cosine, right? Hypotenuse adjacent. Okay, so this time I'm going to show you how to solve for that missing side, just in case. C squared equals A squared plus B squared. Subtract the B over. Square root both sides. So A is equal to the hypotenuse squared minus the other side squared. Oops, sorry. So move the B over by subtraction. Square root both sides. A will be this part. Plug in your X and plug in the 1. If you want to have it all plugged in from the start, that's fine too. I don't really care how you do it. As long as it's legit math, you'll be good. I'm not going to force you to do one way or the other. Just make sure it's clear steps, and you'll be fine. Any questions so far on part B? Okay, so answer the question. What is sine? Yeah. It would be this part over X. Yes. Is that making sense? Right, sine is equal to the opposite over hypotenuse. So once you build a triangle, you should be able to answer the sine. So this outer part is the actual question. This inner part is just helping you build the triangle. Okay. Any issues on any of the steps? Yeah.
Okay, so on the last part, it's like x power 2. And then notice that after the answer is
Yeah, 1 squared is just going to be 1. Doesn't matter. If you write it this way, it's more obvious. Does this make more sense?
okay.
It's implied. Yeah,
Why doesn't the square root also cancel out the square and the
it would have to be. Both things would have to be squared at the same time to cancel it. Like if it was like this, then they would cancel. But individually like this, no. Yeah. If it factored like that, that'd be cool, but it's not gonna happen. It's tempting though, right? Don't do it though. Don't do it. Any other questions?
So because minus opposite over which that's how you go.
Yeah, opposite over hypotenuse is where this came from. That's the answer.
Oh,
So just have all when you're doing these, make sure you have your definitions of each trig function and then have your domain and ranges too. That way you won't make a mistake during 6.3. I'm not gonna force you to memorize anything. Just make sure you know how to apply stuff. Okay? If you want to memorize it, cool. But I'm not gonna quiz you on memorization. All right. Any other questions on example 3? All right. As you click on it, they'll have a help me solve thing. They'll pretty much say the same thing. Change the inside, right? Once you get here, remember it's the same as x over 1. Build your triangle, solve for hypotenuse, etc. And then you answer the question, what is cosine? Okay, same thing we did. I will practice more in a little bit. The next question here, I'm going to leave to you. This is questions about more conceptual questions. What is the domain? What is the range? Those you got to look up in your book. Okay, it's also in that thing I gave you. Let's do this guy here. This is just like the last one, but they have numbers. So maybe it's easier, maybe not. I don't know. We'll see. You guys cool on this page? Okay. Example 4. Evaluate the following. Your answer must not be a decimal or in decimal form. So we'll do the same thing with the triangle. Just in numbers. So basically let theta equal cosine inverse of 12/13. Apply your definition. That's the same as saying cosine theta is equal to 12/13. Knowing that fact, you can build your triangle. So cosine is adjacent over hypotenuse. So put them in the correct spots. Solve for the missing side using Pythagorean theorem or the formulas from the last couple of sections. Either way. You can also remember that this is one of the magic triangles and it has to be 5 here. If you don't remember that, that's fine. Solve for that side. Okay. I'll show you the work. Subtract the A over. Square root both sides. So B is equal to this garbage, which turns out to be 13 squared minus 12 squared, which is 5. So if you want to do all that, you can. Doesn't bother me. But there's a certain set of triangles that always end up as whole numbers, and this is one of them. Okay. Okay. So once you filled out the triangle, what's sine gonna be? Yeah. 5/13. Any questions on the setup? It's starting to make more sense? Okay, I'll give you some practice questions at the end of class before you leave. I want you to solve a few. It doesn't make sense until you do it. If you wait too long, you start to forget what we did. Okay. So sine inverse of 3/5 is inside. So again, let theta equal to that inside part. And then remember that by definition, this is the same as sine theta equal to 3/5. Put the 3 and the 5 in the correct spots according to the location of your angle, right? I put the angle there, so that means opposite has to be here. Hypotenuse is not going to change. This is another magic triangle. This is going to be 4. I'm not going to solve it this time. So what is tangent? Yeah, just 3 or 4. That's it. I'm gonna write a note here in case you forget. This is by definition. Same thing over here. By definition. Okay. Any questions on example 4? The rest is pretty much the same thing over and over again. So I'm gonna give you some practice questions.
Oh, what makes 3/4?
Oh, tangent is opposite over adjacent. So don't forget that tangent theta, which is basically what they're asking, is opposite over adjacent. I think I spelled that wrong, but who cares? Opposite adjacent. Okay.
Thank you.
All right. So this is for you. I want you to try these before you leave. Okay. So it can sink in and you don't forget. Find the exact value. Sine inverse of square root 2/2. Cosine inverse of the same thing. Cosine inverse of negative square root 2/2. Sine inverse of negative square root 2/2. That's the first set. Complete the identity using the triangle method. Those are the ones we just did. Number 3, same instructions, but they are with numbers. spend the rest of the time just practicing and asking questions, okay? And don't feel bad if you get stuck. From my experience of, I don't know how many classes I've taken, about 20 years of math and engineering courses, you always feel stuck and confused and lost every single time. So it doesn't change.
Say for science, right side.
Yes.
What about
Top half.